Of the implementation where we are going to visualize the communities, that is the coalitions that we formed in the previous video. So one thing that we want to do here is that we want to display the nodes in one coalition by a different color and the nodes in the second coalition by a different color, so that we can clearly see the kinds of relationships amongst the nodes inside the coalition and across the coalition. We want to visualize that. So what we can do is we can use the same layout, circular layout. So we'll write nx dot circular layout g. Now if we write nx dot draw, it will just draw the network simply without any added features there. Since we want to display the nodes in a different in two different colors, we will have to use separate commands. So what we can use here is nx dot draw network x nodes. In that function, we will pass the list of nodes which have to be colored with a single color. So what we can write is nx dot draw network x nodes, and the parameters will be first the graph and then the layout, and the third parameter, which is the most important, is the node list. So this list will contain the nodes which have to be colored in one color. So here we want the nodes which are there in the first list, this list, to be colored in the same color. So we'll write node list is equal to first. We can specify the color that we want. Node color is equal to, say, red, and we can also give the size. Node size is equal to, say, 5000. So that was displaying the nodes in the first list. Similarly, we have to display the nodes in the second list. We'll write nx dot draw network x nodes g and then pause, then node list is equal to second. Now node color is equal to, say, we'll change the color here, say blue, and node size is equal to, one second, didn't put a code. Okay, node size is equal to 5000. There's one more parameter which we can use, that is alpha, which basically gives the transparency value for the node color. So we can keep it and we can change it later if we require. So as of now, I'm giving it 0.8. So now we have drawn the nodes. Since we have not made use of nx.draw, rest of the things will not be drawn by default. We are manually doing it in a way. So we have drawn the nodes, we have not drawn the edges, we have not drawn the edge labels, we have not drawn the node labels. So we are going to do that one by one. Okay, so let's first write the labels of the nodes. So we'll write nx dot draw network x labels. So again, the parameters will be g and the layout, and then the font size. Font size is equal to 10, and then font, we can give the font as well by this parameter. Font family is equal to, say, sans serif. I'm sorry, we'll put hyphen here. Okay, now we have drawn the nodes and the labels on the nodes. Now next thing is the edges. So we'll write nx dot draw network x edges. Again, the parameters will be g and pause. You can give more parameters as well. As of now, I think this is enough. Now we haven't yet drawn the labels on the edges. So for that, we'll use nx dot draw network x edge labels. So this is the command. I think we used it earlier as well. So the parameters again will be g and then the layout, and then edge labels is equal to edge labels. We are yet to retrieve the labels. Firstly, we are going to do that after writing this command. So as we did in the previous representation of the graph, we have to retrieve the labels. If you don't do that, by default it displays the attribute name as well. For example, sign is equal to plus, sign is equal to minus. We don't want that. We only want to display plus and minus there. So we are going to retrieve the edge labels in the next command. And apart from that, we can display the font size as well. Font size is equal to say 20, and then font color is equal to say green maybe. Okay, so the only thing left is retrieving the edge labels. So for that we will go up here, we'll write this command: edge labels is equal to nx dot get edge attributes, and the parameters will be the graph and the attribute for which we want to retrieve the values. So this should fetch the latest attributes of sign for all the edges. So I think we have drawn pretty much everything and it should work. So we can write plt dot show. Okay, let me also add one more thing. Let me add a function here, raw input. Now what this function does is it will ask you for an enter before it proceeds. So we want it to pause for a few moments, and then we'll press enter, and then it will display the graph, the network. Okay, let's save it, and okay, and we'll check here. Let's run this. So this is the initial graph, the initial network. Let's take an example of an unstable relationship here. Let me see. Okay, Beerland, Alexandra, and Antrim. This is a triangle which has two positive edges and one negative edge. So this is an unstable relationship. This should not stay for a long time in the network. So let's note down Beerland, Alexandra, and Antrim. So between Beerland and Alexandra there is negative, and these two are positive. So let's see what happens to this particular triangle. Let me close it, and it's now okay. I'm pressing enter. Yeah, this is the final network with the different coalitions colored in a different color. Okay, so here you see blue color nodes are in the first in one of the communities. I don't remember which community. So the second coalition nodes are in the red color. Now if we take a look at Beerland, Alexandra, and Antrim, this has now become stable by so now there is only one positive edge here. So what exactly has happened? Alexandra and Antrim, which were already friends, they have now turned enemies. So this is as per our initial configurations, that this is the kind of relationship that exists for a long time, but not the previous one. So that previous one has led to the animosity between the Alexandra and Antrim. That is one thing to see. Second thing is, if you look at all the red nodes, there are all positive edges amongst them, right? Beerland and Grippa is positive, Grippa and Antrim is positive. You can check all the cases. Similarly, if you look at all the blue nodes, there are all positive edges amongst them. Alexandra, Bercy, Eplex, and Ickley. You see all positive edges are there. They're all friends. However, if you look at the inter edges, which is the edges from one coalition to the other coalition, they're all negative, which is quite an interesting pattern to see. So Bercy to Beerland there is negative, Bercy to Grippa is negative, Bercy to Zemra is negative, and similarly Alexandra to Antrim is negative, Alexandra to Beerland is negative. So precisely we have divided the network into two parts, where people in the first part are all friends, people in the second part are all friends, but the people in these two parts hate each other. They're all enemies of each other. So this is a nice and interesting phenomena to observe.